Yesterday we worked with parabolas in vertex form, and we found out that the vertex was very easy to find if it's in vertex form because, let me write this out here, this shows us a transformation. It moves the parabola 1 unit to the right, and it moves it 4 units up from 0, 0. So that was our vertex in vertex form, so very easy to find. We are going to be working with parabolas in standard form today. Now, going back to when we worked with lines, remember we graphed y equals, let's make that a 2x plus 3, and we also did 2x plus 3y equals 6. This was slope-intercept form, this was standard form. So with parabolas, we have two types of forms. We have vertex form and we have standard form. Now, standard form is f of x equals ax squared plus bx plus c. And we can cross this off. We're going to talk about that in just a minute. So to determine if a parabola opens up or down, you look at the coefficient of the x squared term, which would be this term right here, the a. If the coefficient is positive, the parabola opens up. If the coefficient is negative, the parabola opens down. So when we're graphing parabolas, we need to start with the vertex. Okay, so here we can't see what the vertex is. Let's go down to our example here. We can't see what the vertex is, so we're in standard form. We have to find the x-coordinate of the vertex by doing negative b over 2a. So coming down here, this is a, it's 1. This is b, and we want to take the sign with it, and this is c. All right, so we find the vertex for the x-coordinate of the vertex by saying x equals negative b over 2a. So here's b, so it's going to be x equals a negative negative 4 over 2 times 1, because a is 1. So that means x is going to equal 2. So again, I'm going to ask you to put your vertex right in the middle. And then if we're going to go, so if we put that at 2, we want 2 points to the left, so 1 and 0. And 2 points to the right, so 3 and 4. And now let's find our y-coordinate. And we can find our y-coordinate by substituting the value 2 in here. So we're going to go 2 squared minus 4 times 2 plus 3. So that's going to be 4 minus 8 plus 3. That'll give us negative 4 plus 3, which is negative 1. So we can put negative 1 here. All right, let's go ahead and graph that. 2, negative 1. And we're going to graph our axis of symmetry. Remember that for all of our parabolas that we're working with, they're going to have an axis of symmetry that is vertical because our parabolas are opening up and down. So we graphed the vertex, graph the axis of symmetry, which is going to always be the x-coordinate of our vertex. So x equals 2. And yesterday I said, remember, just think of axis that has an x in it, so we use the x-coordinate of the vertex. Now, one thing that we didn't find yesterday was the y-intercept. The y-intercept is very easy to find if you're in standard form. We just let x equal 0, and we graph it if possible. So sometimes it's going to go off of your graph, but if you can graph it, that's an easy one to find. So if we set x equal to 0, this is going to be 0, that's going to be 0. So we have 0, 3, and we already picked the point 0, so we can say 0, 3. That's our y-intercept, so we can graph that at 0, 3. And now we're going to find 1. So we're going to say when x equals 1, y is going to equal 1 squared minus 4 times 1 plus 3. So that's going to give us 1 minus 4, or negative 3, plus 3 is going to give us 0. So we'll graph the 1, 0. And remember, you need 5 points. Now, if you've done your work correctly here, then these should just reflect over here. So this would be 0 and 3. So we can go to, oh, let me move this down. That's not at 1, 0, so we need to slide it down here. 1, 0 and 3, 0. And then we have at 4, 3. So now we can go ahead and graph that parabola. And you're done. We have our axis of symmetry, which is x equals 2, and we have our 5 points on our parabola. Okay, you have one question to try on the other side.